Cool. All right. So let's do the formula sheet first. Just to remind you guys, you can lose points in the formula sheet if you are foolish enough to put stuff on there. It's not something I say you can have on there, right? So we're going to put the formulas up here. I'm going to ask you guys if there's any suggestions for other formulas. Just we haven't gotten a lot of formulas yet, to be honest. Chapter 1 was all definitions, as you well remember. Chapter 2, we got, this might even be one I wouldn't put down if I were you, but you certainly could. What's the difference between those two? Yeah, one's population, one's a sample. I like it. Population so far, the Greek letters, so it won't hold up that way for a while though. But mu and sigma, population, x bar and s, sample. See good?
Review.
Not really. We're making the formula sheet.
Okay.
Yay. So you're going to bring this with you to the test. I'm not going to have one for you. You probably want to double check the formulas against the book or something to make sure you're not reading what I'm writing incorrectly.
So we have to put what are you?
No, you're allowed to put formulas. That's why it's called a formula sheet. Huh? No words. You can't put next to this mean. You can't put next to this population. I'm so evil. You'll get over it. And then, of course, we had standard deviation. This is one for the population. This is variance, population variance, and then the sample variance. So those actually have a difference in the formula, right? Hopefully everybody understands the n-1, how we look at that. Adjustment for it being a sample.
So the sample is the one and minus one?
Total. Yeah, so also sample is the one that has R letters. Population has Greek letters. I like it. But to be honest, these are really the same, just with that one little adjustment for it being a sample. I like it. I'm missing a whole little group right here. It's weird. Okay. Let's see what else we have. Class width, I'm not going to let you write down. You got to know that. How do you get the class width for a histogram? How do you get the class width for a histogram? Yep, high minus low divided by number of classes. So range divided by number of classes. That's it. I like it.
Wait, can you review that?
We will in a minute.
Oh.
I don't want to get it mixed up with what you're allowed to have. You can put a z-score formula down there. This one, you can put this one. They're really the same exact thing. Z-score doesn't care. Population sample, what you're looking at, it's always the same. Let's see what else. What am I missing? You could put mid-range down there. High plus low divided by 2. That's the one word you're allowed to have on there. Just before somebody says, "You thought we could have words in there." So there's no symbol for that. Mode is an idea.
Is it an H?
Say again?
Is it an H?
This poor little dude, yeah.
Oh.
High plus low divided by 2. The middle of the range. Kind of makes sense. Anything else you think I'm missing up there? It's very possible it happens. You guys can make suggestions. You're all like, we didn't remember all that shit, Jeff. What do you want? Yes?
What is the one underneath the standard deviation one?
These are two these are two variances, of course, right? And then you take a square root to make it a standard. Now, if you want to, you could. So this is the population one, of course, right? And this is the sample one. That's why it's got the little adjustment, and that's why it's got R letters, not Greek letters. If you want to, you can write with a big-ass square root on it, right? But I don't see the reason, but if you want to, I don't care. It's the same damn formula. You with me? And the same thing with S, with big-ass square root on it. Right? In case you think you're going to need it. But if you get the variance, you can take the square root. It's amazing. So, you know, I don't care. You can put that down there, same formula. Anything else you think should be up there? What about percentiles? That's a process. You got to know the process. Two-step process. I like it. I actually make you understand shit. I think too many teachers just give you too much. You get too used to it. And then you hit me, and I'm an asshole. That's too bad. Anything else? I mean, I'm wide open to suggestions right now. Anything else you think should be up here? Okay, this is it. This is all you can have. That's plenty. Anybody? Now a few more people popped in. Anybody else need a copy of the practice test? Did everybody get one of those?
Yeah.
Yes, you need one?
Not really.
Okay. I'm so happy. Okay, so today is really kind of up to you. This is your time to ask. If nobody's saying shit, you got the floor, so you can ask whatever from anything, from the practice test, from homework. Yeah.
From the practice test, I had a question for 1C. I'm still confused of how to do that.
Oh, okay. All right. Let's do that. Oh, do this before this thing freaks out. Boop. Real quick, before we do that, two things. You guys do remember I put videos up there. So, for example, if you didn't get all this, it's up there on the YouTubes after this afternoon. Up on the internets. And I do have office hours, right? That you can come visit me and ask questions and stuff. It's crazy. I am on the other side of the campus, but we call this the other side of the earth over there. It's pretty far away nowadays, but still I'm over there. Okay, everybody got this stuff here? Okay. So if you have anything else on your sheet, and also let me say this now, I'm going to collect the formula sheet with the test. If there's like half of it ripped off or the stuff scratched out, no, I don't know when that happened. Do you understand? Okay, so nice clean sheet with the formulas on it. I like it. Cool. Okay, so number 1C. Let's actually do 1A real quick so that 1C is a little bit easier. Who's done this already? Who got 1A on the practice test done? Okay. So what's your stem and leaf look like?
2, 3, 4, 5, 6, and then 9, and then go down to
Uh-huh.
4, 8, and then go down 0, 2, 4, 5, 7, 8, and then go down 0, 2, 3, 5, and then 6, 3,
I like it. Cool.
and then key 29.
I like it. So key 29 means 29. Sweet. Because this could mean 2.9. It could mean 290.
Can you just put like an equal sign instead of like the means?
Okay, sure. Yep.
The whole key, because obviously I missed that class day, but what, I don't remember.
Without this,
Uh-huh.
I don't know what that means. It could mean 2.9.
So I can use any number and just tell you the key.
Well, the key better make this stuff match up with what the data is. So the data is 29, 34. So what does this mean? 2, 9 means 29. So 4/5 is 45.
Okay. So I can use any number and just tell you what it means? Or
Yeah, you can pick any of these. Any of those.
Okay.
Yeah, just give me one representative example so I can read the whole thing. That does not mean write each one of them because then it kind of defeats the purpose of a quick summary, right?
Okay.
I've had that happen before.
Cool. Thank you.
You're welcome. It's like having one scale on a map. You wouldn't say, well, this is this much and this is this much. You know, just one scale. I can see where everything is. All right. Now, before you do part C, we need part B. Because part B is the table, and then from that, I set up the histogram, right? So part B, I got to figure out class width. Yeah. So it's going to be
5 minus 1.
divided by number of classes.
I thought you get to choose your class.
Well, what did I say here? What? I didn't say the number of classes. I didn't say. Well, what's the smallest number of classes allowed? 5. And normally it's 5 up to 10. And for smaller sets of data, you use 5. As it gets bigger, you use 6, 7, 8, 9. So if somebody used 9 on this one, it's like, shit. So we should probably use 5. All right. But on the actual test, I'm going to let you pick. So some of you guys are going to make 5, some of you guys are going to make 6, maybe based on if it goes into the top or not. Let's just use 5 on this one. Anybody do this one already? Use the different number? Did you guys use?
I use 9.
Use 9, okay, all right.
Does that work?
Now's the time to do that because you won't lose any points or anything.
What do you mean 9 or
Supposed to use
5?
15.
Number of classes. No, dude. Number of classes, right?
I'm on.
What does every rectangle represent? Each class. So you're really dividing by the number of rectangles you want to end up with, not the number of data points. The number of classes you want to use. Yes, sir.
So for B, we're not using this data?
Of course.
Okay, that's it.
But how do you find the class width? Well, it's how wide the classes are. So it's got to divide by the number of classes to see how wide they end up being, not by the amount of data. Is that cool? No, dude, now's the time to make that mistake, right? Not on the test. Now's the time to make the mistake.
So it will be 5.
Yes. So like we just said, well, let's use 5 classes. And the highest is 63. The lowest is 29. So you get 34 divided by 5. 6.8. So you always round it up. So you don't make it harder on yourself. Don't make 6.8. Yeah.
So since I put the whole 15 data, that's what I put, and I did 63 minus 29 got 34, that divided by 15, I still got 6.8, so I rounded up to 7. So it's basically the same thing.
34 divided by 15 is like a little more than 2, because 30 divided by 15 is 2. So you must have put it in the calculator wrong. If you had a 15 down here, ain't no way it's almost 7. 15 goes into 30 twice.
Yes, yeah.
No guess. Yes. So when you put it in the calculator, maybe you got lucky and left the 1 out, and you ended up doing what you're supposed to do. You with
I
me?
believe.
Does that make sense?
Yeah. no,
Okay, all right. That's what I think might have happened.
So my data's not right now. Yeah.
Okay, I like it.
So 5 divided from the total.
And again, remember now, guys, believe it or not, and I try to teach it this way, a lot of what we do in statistics makes physical sense. Right? I got so far I want to go, and I got a certain number of things I want to cover that. So how wide does each thing have to be? Well, the distance I got to go divided by how many things I want to use. That's how wide, so that if I got to go really far, then each thing's going to be wide to cover that whole thing when you put them all together. That's the idea. It's a physical idea. Because I've got to come in with some understanding of things. Okay. We doing okay? I can't read you guys at all. So what the hell does that mean? Do all this shit, and what does it mean? No, I already know I want 5 classes. 7 is how wide it's going to be.
Yeah.
All right, so now I can set this up. Where's the first class start?
29.
29, I like it. Where's the next class have to start?
36.
36, so what number is going to be here?
35.
35.
42.
Yes, yes. Does this seem familiar? Hopefully it does. Add 7, add 7, add 7, add 7, add 7, add
Wait
7.
7. Oh, I remember now. The tutor said I could use any number
For what?
for the class width. That's what it got me.
Whoever that tutor is, you need to evaluate them, fill something out, and
I
say,
didn't know I was doing it wrong.
what's that?
I didn't know I was doing
No,
it
no, no.
wrong.
I just said, make sure that that tutor gets schooled in the correct way to do things.
Oh, okay.
I don't need some tutor spreading some misinformation.
Oh, okay.
Now, but the poor tutors, most of them have only taken one stats class, and
Yeah.
they do have to get recertified every 6 months, I think. They have to go through this little My Math Lab statistics thing. But they've only taken one stats
They
class.
didn't know anything when I went there. Only
Okay.
marketing.
Okay. Again, I'm not in charge of the tutoring. If you're not filling out evaluations after having a bad experience at the math lab, then how in the world are they ever going to change it? Right? That's why they have evaluations. Okay? If you want to get helped, make sure the place you go to get help gets set up the right way. Okay, so pretty cool with what we've done so far. I mean, we've done this before. And now, the frequency. How do I find that out?
Just how many numbers?
Yeah, so how many numbers are between 29 and 35?
2,
2. 36 and 42?
3,
1, 2, 3. 43, 49,
5,
5.
4,
50 to 56 is 4, I like it.
and 1.
1. Poor little 1 do down there. And what should all these add up to be?
0. No.
15.
Yeah, why should they add it to be 15?
So there's 13.
Because there's 15 things I'm supposed to be counting. Right, there's 15 total numbers that have to find a home, and they all found a home. Yeah. So if you get 13 there, don't just keep going. Take a second and see what did you miss. Okay? Or if you realize that I'm saying turn your papers in, at least go, I ran out of time, but I know it should have been this. That at least tells me, I might give you more partial credit if you tell me what it should have been. You didn't have time to check it. Does that make sense? So like when you get probability and somebody gives me a negative probability, oh shit. At least say something. I don't see what I did wrong, but I know it shouldn't be negative. Don't make me worry about you that much. What's the next thing I figure out?
Relative.
Yeah, real freak.
And then you do 2 divided by 15.
Cool. So it'll be 2 out of how many total? A pure percentage?
13.3.
13.3?
And then 3 divided
3 out of 15 is a nice one.
20%.
20%.
And then
5 out of 15 is sort of a nice one.
33.3. 4 out of 15.
4 to 15.
26.7. And then 1 out of 15.
Poor little 1 out of 15.
6.67.
Sure. Then you can add the percentages, and they should be at least close to 100%.
So you don't round right there, right?
Yeah, no, I mean, I was just going, well, how about you could make this 6.7?
So
Right?
you do round or you don't?
You can, yes.
But you don't have to.
What are we going to do with these percentages? What are we going to do with them? We're going to graph them. We're going to graph them. Can you graph the difference between 13.3 and 13.33? No. No, when I graph, I can barely graph 13 exactly, right? Do you understand what I'm saying? I mean, so I know a lot of you guys get scared because Jeff needs you to round certain things to certain amounts of things. This is going to be done by hand. We're not going to calculate anything based on these. So it's fine to round them quite a bit. I'd say don't round it to a whole number, maybe 1 decimal place, just so it gets closer to 100% so when you check it. Okay. I like it. Now we can finally get to the real question, right? Because we had to have this so we can make that easier. And we had to have that because that's where the histogram comes from. Okay. So now, I don't know if anybody does the inequality method that I showed you guys.
Yeah, I do.
Yeah? So if you do this, the first one would look like this. And then when you make a histogram, you don't have to worry about going up and down by a half. That's the nice trade-off. So some people are scared of this because there's inequalities in there. Ooh. And X is, oh. But it makes it a hell of a lot easier to do basically everything. So now what's my, so I'm not going to do it like this. I'm going to do it using these. Which means when I go to set up this axis here, what do I have to do? Probably what I just said.
On the bottom.
So what's going to be down here?
28.5.
Good. 28.5.
35.5.
And then you just keep adding 7, because it's 7 apart.
Yeah.
Do you see how this is really kind of unsatisfactory? It's like, what? That's 6. I thought it was supposed to be 7. Well, there's 7, but now you can see the real 7, right? There's 7. It's hidden when you do it that way. It's kind of hidden, the 7. Now just keep adding 7.
32.5, 39.5,
And then what's this other scale? Oh, I'm sorry. What's the label down here going to be? What is this physically? My data, what is it doing? What is it measuring?
Air quality.
There it is. You just read the sentence there. Air quality measurements. You could say from Townsville or whatever. This is going to be relative frequency, because that's the kind of histogram I want you to make. If I say make a frequency histogram, make sure you use these numbers. But I want you to make a relative frequency histogram. And how far do I have to go up on this scale here?
40.
Yeah, but at least up to include 33, right? 33.3? So it depends. So if I go by 5s, 5, 10, 15, 20, 25, 30, 35. That's plenty. I like it. Don't go up to 100. Because then you turn in a little thing like, I'm like, use more, good Lord. No reason to go up to 100 if nothing goes up close to 100. No reason. Just go up as far as you need to get the highest one. That gives you the best display of it. 5, 10, 15, 20. So then how tall is this bar going to be? No.
13.
Yes, 13.3. So right there roughly. And then of course
20.
20. So this should not be that horrible. This is not that horrible. This is horrible. You'll have a great time later.
Because I was wondering why like my bars are so small. Because you know how.
Oh, because you made the scale too.
No.
Oh, because
I
you're
was
using the
wondering-
2, 3, 5.
Yeah.
Oh shit.
That's what I was doing. Yeah.
How tall is this one? Let's see, where am I at? 33, right? And then 26. And then almost 7, so like right there. Would you say that's roughly normal?
Yep.
Yes, it's roughly normal. Starts lower, goes higher, goes back lower. It's not perfectly normal. It's nowhere near perfectly normal, but it is roughly normal. Maybe if I took a larger sample, it would be normal. Small sample. Is that cool, you guys? Is that all right?
That was the question I asked.
1C, right? Okay.
You told me to do something else. I just threw it.
All right. How the rest of that go? Have you guys tried that yet? No. Obviously, the first priority is to do the homework. And when I say do the homework, I mean do it. Actually do the homework. Yes?
Can you go over D and G? I just want to check.
If you have a question about how to do it, we can go over that. But, I mean, I've got the answer key I'm going to give out in a minute. Yeah.
Okay. I just got a question for the mean.
Yes.
For D, I got 45.7. Basically, what I did was.
No, you got it.
Yeah, right? Oh,
Yeah.
that's not good.
Let me show you guys something on the calculator. Anybody want to borrow a calculator? You know the rule. You know the. I brought them, right? Where did I put them? Did I bring them? Oh, it's over. Shit. Oh, yeah, that's right. I thought I brought the bag. I did. Thanks to God. Make sure it turns on before you get too far. Yeah, you don't want me making collect calls.
Today is the lighter.
Yeah, yeah. So I'm going to show you the shortcut of how to check your work. You guys with me? Check your work. I'll tell you this, after this first test, I'm never going to make you use the x minus x bar kind of table to calculate that. We'll just get it using what I'm about to do after this first test. So on the homework and on this test, you better do it the long-ass way. Look at Jeff trying to log in. So hopeful. Maybe I'll just... That takes forever.
This one isn't turning on.
Poor little dude. Let's see if this one works. That one's mine. Hey, I knew mine was somewhere. There we go. Sweet. Preparing Windows. Oh. Hey, there we go. Oh, I like it. I don't even have it here. Alright, you can't use that. Alright guys, so system initializing. No, just saying it right. Alright guys, so you hit the stats button. Find where I can do this without glare. Hit the stat button you see here, right? We've used this edit before, edit. And this is where we did we actually had the calculator do the table columns for us, right? But let me show you the shortcut to check this. If I put all this data in here, so 29.
I'm trying to work it. How do you get there?
Okay, let me help you guys out. See the stat button right there?
Oh, there you go.
That's a good guess that that's going to be important. And then you go to edit, so that's where you can edit the list and put stuff in there.
Okay.
Let's all put this data in here. 29, 33. Very often you're going to have it in here already, so it's just so you can sort it. All right, thank God. You always want the last one you put in to be in the position that's the sample size. Thank God that's 15.
How do you figure again?
If you have stuff in a list, you go up to the list, clear, enter. If you hit delete, then the list is going to go away. That will freak you out.
Thank you.
You're welcome.
I don't know who's trying to do.
Everybody okay? We're just putting numbers in there, right?
What numbers?
Numbers for the problem we're just doing.
How do you go back to one?
If you did some of the problem, then you already have an order. They don't have to be in order. Just get them in there. Yes, sir. Oh, if you deleted it? So if anything ever freaky is happening with the lists, you hit stat, number 5, set up editor. That just brings it back to normal. Hit the stat button. Stat button's right there still. And then number 5. You alright? What's up? Okay. Hit set up editor and then enter. You go back in, it should be back. Let me know if it's freaking out. Okay.
Thank you.
Come on, coach.
Alright. What's that?
I was like a note to self never sneezing.
I just like that. I have to point out when it's interesting things. That was the anti-sneeze. So, yeah, you didn't have any sneezing. So once you get all the data in, kind of makes sense. This first selection is all about, just basic, putting it in, sorting it, clearing it. That if I want to do something, if I want to analyze it somehow, I've got to go over to calc. I want to calculate something. Let me ask you, how many variables did we put in? This is where I get nifty answers. How many variables did I put in?
11.
Nope. One. One variable with 15 values. Right? One variable. What variable is that? Air quality measurements. Okay. So I want to do one var stats. If I have 2 columns worth of stuff, then I want to do 2 var stats. So one column is one variable with a lot of values. So if I do one var stats, so go, and again, how do you get here? Stat, calc, one var stats. Enter. Now if you have the older calculator where it just says one var stats and that's it, you can just hit enter because it defaults to list 1. Here for us, we got to make sure it says list 1. Don't worry about the freaky list. Go down and calculate. Make sure that the freak list is empty. Everybody with me that wants to try and play along? You guys with me? Hit calculate and look at all the stuff it tells you. What's that first thing it tells you? The mean. Then it tells you the sum of the x's. That's nice. Which one of these are we going to use? The first one. Why does it give me both of them, stupid calculator? Why does it give me both? What's the difference here? Yeah, and the only reason it says Sx and sigma x is if I have 2 variables, they call one of them x and one of them y. And later this semester we'll come back and there's another way to look at this. But the calculator gives me both because it doesn't know if it's population or a sample. It's just a poor little stupid calculator. We're the humans with the brains. We got to know which one to pick. So don't get all excited and say, oh, I can choose this one. No, it's a sample. You got to choose this first one.
Sample?
Yes, we all know this is a sample, definitely, right?
Yeah.
No, I do.
So we don't have to like show our work on the test.
Okay, let me. Okay. So, all right. I made this really well. I thought I did. I tried to make this really clear. Yes, you will never, or very rarely, in this class will you be able to just push a button, get a number, put it down. Okay. If you had a teacher that used to do that for you, you don't have that teacher now, right? Okay. Now, why do I do that? Because my job is to teach you. And if you have a calculator doing your shit for you, you are not learning anything. Calculator passes the course, you take it again. That's not very good, right? So, like I said earlier, I'm showing you a way to check your work. Now, what are you going to do on the test? What are you going to show me? You're going to show me the work, right? So it's really nice, though, to be able to have a way to check to make sure it's right before you turn the damn thing in. But it is nowhere near good enough just to copy it down. You guys with me?
Yep.
Okay. All right. Poor little dude. If you look down here, what's this last 5 stuff it tells you? What's the last 5 things? What's the other? Yeah, hey, all right. 5-number summary. The lowest, Q1, Q2, Q3, the highest. So if I ask you to make a box plot, you can check your work here. I like it. Okay, I like it. No matter how much I say that, I always have somebody that writes in their test, I did this in the calculator, this is what I got. Okay. Anything else from the practice test you want to look at right now? Is that? Somebody asked me, what'd you ask me about? Oh, yeah, this is me just saying I want to show you something, right? Okay. This didn't come off a question. This is just Jeff doing weird shit. So just to review real quick, because I didn't have the camera pointing the right way, you put your data in. There it all is. You go to stat, calc, 1 var stats. If you have the old calculator, you just have to hit enter because it defaults to list 1. If you want to do 1 var stats on list 2, you just put list 2 in. Second 2 to get a list 2 in there. See that? There's list 2, so you do second 2 to get list 2. Otherwise, you just hit enter because it defaults to list 1. Here with the newer calculators, you just make sure that that looks like that. Calculate.
Goodbye, him.
All kinds of stuff. Yes?
Are you still going to go, I have a question about this.
Sure, yeah. I just want to make sure that it was all on camera.
Yeah. So for G, like I knew my low and I knew my high, and then for quarter two, it gave me like a number, like when I did the math, it gave me 7.8, I rounded it up to 8, and I chose the 8th number, 45, and then quarter three, I did the same thing, I chose the 12 number, but then quarter one, it gave me a whole number. What do I do if it's a whole number?
Whoa, Quarter one and quartile one. All right, let's do that. Let's double check what we're seeing up there. Ooh, that's neat. I didn't know. Yeah. All right, so let's check what the calculator is showing us. So in order to find Q1, how do I do that? What's the method, what's the process I go through to figure out Q1? What's Q1 mean?
25%.
25th percentile, I like it. 25% of what? So the first step, 25% of 15. Why 15?
That's the total of the
Because it's freaking 15 numbers. So if I want to get the number that has 25% below it, I'm going to go 25% of the way into the list.
15, I guess, is the
It only makes sense. So what is 0.25 times 15?
3.75.
3.75. And then, of course, you round it up to,
4.
you always round whatever that number is, even if it was 3.02. You would round it up to 4. So the fourth number is the answer. What's the fourth number?
40.
40. Thank God, right? Are you guys with me? Now, I don't know if some of you guys remember, I can figure out Q3 right now. Q1 is the fourth number from the beginning. Q3 is the fourth number from the end. That only makes sense. They have to be symmetric. There's top 25, bottom 25%, they're going to be the same. If you don't get that, then just do all the same work with 75%. You'll get the same answer. Oh, it's going to be an interesting semester. No reaction to anything I say, so I have no idea if you guys got it or not. You guys okay with that?
So if it's 2Q, it's 50?
Yeah, Q2,
Yeah.
second quarter, so it's 50th percentile.
It's like a quarter.
Yep, that's why we have a Q, because it's a quarter of the way in, 2/4 of the way in is 50 cents, 50%, 3/4, 75 cents, 75%, blah, blah.
Ready?
Yes?
Yeah.
Okay. And this one would be the same way. It'd be half of 15. I like it.
And the Q2 is how much?
Okay. Anything else on this? Or you know, it's you don't have to only look at the practice test, right? It could be anything. It could be from the quiz. It could be from homework. Today's complete review day. It's whatever the hell you want to look at, talk about, have explained.
I was trying to do one of the problems in the homework.
Yeah.
Like standard deviation, and I couldn't figure out how to put the list in the calculator and make the next column.
Oh yeah, okay.
what I wanted to do.
So let's do the one we have in there already. As an example, right? So how do I, if I have a sample, I need this formula here, right? So I need to have those so I can actually add them up. So if you cover the sum symbol, it'll tell you what column you have to eventually have made so that you can add them all up. Do not put stuff here in here that doesn't make any damn sense. Because what is x? A lot of things. Because what is x? X represents all the values. So how could you put something in for x when it's a bunch of things? You can't do that. Don't just write 7 and then write 8 on top of that and write 10 on top of that. No. So I need my x's. I need x minus x bar. What was that? What was the mean for this? It was 45.7, right? So it'll be x minus 45.7. And then I'll have to do that squared. So really, notice this will be L1. So what I want L2 to be, I want it to be L1 minus 45.7, right? And what I want L3 to be, I want this to be L2 squared. Can you write that on your formula sheet? Well, hell no. Because I said so. Okay. All right, let's take a look here. Hire a camera person or something. Now you do not have to use a calculator. You don't have to use a list in the calculator to do this, but it sure as all hell makes it quicker. All right, so if you did this with me earlier, everybody's got this data in here already. Let me do this. Gotta put a little. Whoa, that is not good, Jeff. Oh well. Come back. Okay. So now I go over. Now here's the trick. I don't want to put something in a single position. I want to make the whole list something. And what do I want L2 to be? Well, in this case, no. What do I want the second column to be? L1 minus the mean. I want to make the x minus x bar, and then I'm going to square them. So this will be L1. L1 is right above the 1 key, right? So it's second 1 for L1 minus 45.7. Is that cool?
I got an error.
Minus.
What's it say?
Error.
No, it always says something more specific. Syntax?
I lost it.
So funny being a teacher, but knowing how it feels to be in IT.
She's 21. What? 1 minus what?
So L1 minus 45.7. Make sure you use the right minus button, right? You guys notice there's a negative button and a minus button? Yeah? Okay. Now if you wanted to, real quick, if you wanted to right now, you could hit second quit, get the hell out of the list, and I can go sum up L2. What should L2 sum up to be? 0. That's why we had to make another column, because the stupid things always would make 0. Now we rounded the mean a little bit, right? It wasn't exactly 45.7. So if I go to list, and I go to math, I can sum up. Number 5, I can sum up. Ooh, shit. Try again. Stat, list, math. I can sum up L2, just real quick. I haven't made L3 yet. See, it says negative 0.5. That's almost 0. Why is it negative 0.5? Why isn't it exactly 0? Because we rounded the mean a little bit. Okay. So the more you round, the worse it could be. But it should be relatively close to 0. That's kind of a way to check to make sure everything's going well. Now go back into the list, stat, edit. Now I want to make L3. What do I want the third column to be? Yeah, square those suckers. So I want this to be second 2, L2, and then there's a square button. That's nice. Squared. Enter. Bam. And you're going to copy that down onto your paper. Now, to do this formula, now I want to do what? I want to sum that third list, because that's going to be what goes in the top. Right? That number is going to be the sum of these. I'm going to replace the whole top with it, because that's what it's asking for, the sum of these. So if we go back, always quit, like get out of your list. Second mode to quit, because otherwise it might try to put the answer into the list. That sucks. So then you can go to second stat to go to list. I want to do something to the list. I want to do some math to the list. I want to sum the list. Sum L3. And I get that. Okay. What's up?
You can think into the second list and then I went to like the south of
Second quit. And then you're, yeah. You want to quit because otherwise it's going to try to put the sum into the list. Yeah.
That's what it did.
Yep.
Thank you.
All right. So now that's good. The variance is, what goes up here? What's down here? 14. One less than how many? Why one less? Because it's a poor little sample. We've got to help it out a little bit. Now let me show you. I don't want to keep turning that stupid thing around. Watch this. It's kind of nice. If I just do right off of what I have, watch it. Just hit the divided by button. It's going to assume I want to divide by the answer of what I just got. Answer divided by 14. Bam. And then I want to take the square root of that. I can hit second square root. Did I hit the square root button? No. Second square root. And then here is the temporary memory, that little same thing, ANS. It has the last number that showed up on the screen. Second negative, and it's going to be the square root of that. Bam. It's a really cool little memory button to know, the little ANS, the one that's right above the negative, that holds the last number that was on the screen. That was not a very long number, 73.525, but very often it's going to be very long. And the more you round it, the more off your answer is. So why not round it at all? Right? Just tell the calculator to go back and do something with that stupid big ass number. So that tells me this is 73.525. And what's that last thing? What's that last number represent? Standard deviation. Square root this guy, I get the standard deviation 8.575. Roughly. Remember, at least 3 decimal places. And please, dear God, know how to round. It says 6 next to the 4, so make the 4 go up to 5. I always get a few people that don't know that. And I don't know if you remember, but that's the same thing we had in one of our stats where the S was 8.575. Yeah. Right. Well, what does this mean? What's the standard deviation tell you? What does this mean? It's how far the data is away from the mean on average, right? That's where the formula comes from. The formula is an averaging formula. It's adding up these divided by how many there are. I know it's a little adjustment, but get past that. It's basically how many there are, right? If there was a billion minus 1 is still frickin' a billion. $1 billion, I dropped 1. Who gives a shit? I basically still have $1 billion. I really want you guys to see that. It is an average. You can see it. Sum them up and divide by how many there are. It's an average. It's an average distance from the mean to the data points. How far away they get on average. That's why it's such a beautiful number to calculate. It's a nice thing to know. It tells me the spread of my data. Cool. Okay. Let's see. Yep. Okay. Oh, what about part F? What the hell does that mean? If I said, if I weigh 190 pounds and I said, guess my weight, I already told you my weight, but if I said to somebody that didn't know, I said, guess my weight, and you could be within 5 pounds, well, how far would I let it go and I'd say you're still right?
130.
So I weigh 190,
85 and 95.
and I say be within 5 pounds. So 185 to 195. What'd you do? You started at the middle, and you went down and up the amount I said to be within. So when I say within 1 standard deviation of the mean, start at the mean, go down 1 standard deviation, go up 1 standard deviation. That's what it always means. What would within 2 mean? Down 2, up 2. It's amazing. So what's the mean again? What's the mean again?
45%.
And then I want to go down 1 standard deviation. minus 8.575.
So right now, what are you figuring? What is that based on?
Everything I just said. So this is going to be, how do I figure out, in order to figure out the percentage of the data that's within one standard deviation of the mean, I got to figure out what within one standard deviation of the mean is. If I said what percentage of the data is in the 30s, I don't have to, I can just look and see, well, what's in the 30s out of 15? I'm done.
Oh, okay.
What percentage is within one standard? Oh shit, I better set that up so I see what data I catch. So if I subtract 8.575 from this, where do I end up?
37.
And then if I add 8.575 to this,
54.2.
what the math boy did, let's see. So I caught every data point that's in between those. So what data points did I catch? Of course, it's easier if you have them in order.
38, 40.
Yeah, I caught 38, 40, 42, 44, 45, 45, 47, 48, 50, 52, 53. Yeah. So I caught 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Got 11 data points out of 15. It always makes me sad how little percentages are understood nowadays, and it's not really your fault. They just aren't doing anything about teaching it correctly earlier. Percentage is always part out of whole. Right? So if there's 11 I caught out of 15, and you just throw that in your calculator. 73, roughly. Yeah. So that's how you do that problem. There's a problem just like that on the handout we had for standard deviation.
So that would be your answer.
Yeah, this is the work, and there's your answer right there. Remember, what was it supposed to be for a normal distribution? If it, within one step would be what percentage for a normal distribution?